Hello. Sorry I couldn't be with you guys today. So I am going to be going over in this video defining transformations. You should check your notifications on Khan Academy because I gave us the same questions. So this kind of falls in line and like some of the proofs. I will be with you guys in class tomorrow. So you do need to complete this assignment, and I'm going to be taking attendance based on whether your assignment is done. So you will be marked absent if you do not finish the assignment, which you should because I'm giving you all the answers right here. So the question number 1 says a certain mapping in the xy plane has the following properties. For the point A, the image A prime is the same point as A. So that one so far isn't really going to help us determine translation or reflection or rotation. Well, probably not translation because that's moving left to right, up or down, but it could be a reflection or a rotation. Rotation if it's the center. The second one says a point P that is not at A maps to a point P1 clockwise along the circumference of a circle centered at A and with a radius of AP. And then it creates an angle PAP prime. Well, when I hear it talking about clockwise and creating a circumference and a circle and radius, that should clue you into only one of these, translation, reflection, rotation, ever really talked about a clockwise or counterclockwise movement, and that would be a rotation. So basically, we're going to have a point P, could be like along a circle here. All right, sorry, it wasn't P, it was A. Oops. A is the center. A and A prime are both going to be right here because they're the exact same point. And then you could have a point P on the circle, and then another point P prime. These should be the same distance away from the circle if I drew like a perfect circle, and it would create an angle theta of this P prime. So it is a rotation going clockwise. All right, next one. It says Sasha tried to define a reflection across the line L. Any point Q on line of reflection L maps to itself. So looking at our choices, we're trying to see if a counterexample shows that Sasha's definition does not fully define a reflection. And each one mentions the Q goes to Q prime. So that one looks good for each of them. The second says any point P not on L maps to a point P prime such that P and P prime are the same distance from L. So example A does show that P and P prime are both the same distance from L, and they are reflected across the line, so that's good. However, example B does show that P and P prime are the same distance from L, but we see that they're both on the same side of the line of reflection, and that's not what it means to reflect. It means we should have one below because we're reflecting over the line. But she didn't mention anywhere that one has to be on the other side of line L. So B is a great example, counterexample of why her definition isn't quite right. For number 3, it says a certain mapping in the xy plane has the following properties. Every point moves m units horizontally and n units vertically. If m is positive, the point moves to the right. If m is negative, the point moves to the left. If n is positive, the point moves up. If n is negative, the point moves down. So let's say I have my original point here is A, and I'm being asked to move m units and then a negative n. We're going to make it a negative n. So m would move to the right, m units, and then n is sorry, I said it was going to be negative in this example, so I'm going to move down. And this would be where my new point would be. And we have to determine, with that kind of movement, would that be a translation, a reflection, or a rotation? And in this case, we should notice that it's just sliding from the left to right, up or down, and that is what we call a translation. Number 4, it says Jack tried to define a rotation. For the center point C, the image C prime is at the same point as C. For a point P that is not at C, a rotation of theta degrees about point C creates point P prime such that CP equals CP prime and creates the angle theta. What mistake did Jack make in his definition of a rotation? So let's go ahead and check each one of these as we go until we find one that we think is right. Jack needed to include the direction of the rotation. So we have to think, is it important to know whether we should have reflected clockwise or counterclockwise? And that answer would be yes, it is important. I could have the center point C here and a circle C. We'll pretend like that's a perfect circle. It's clearly not. And if I had a point P here and move to P prime, this right here is a clockwise rotation. However, I could have the same circle P, and if it was going counterclockwise, the same amount of degrees, it would end up, we're going to pretend like this is the same degrees over here. So it does create a different spot. So the direction of rotation is important. So we should put the Jack needed to include the direction of rotation. So that is all. Please make sure to complete the assignment so you can get marked for attendance, and let me know if you have any questions. Feel free to email me.